All right, let's get started on the E.2 learning target and the or the 5.2 learning target. And that is I can use properties and relationships of similarity to justify figures are similar and solve for unknown measurements. So we're going to be looking at page 67 of our notebook for the notes today. Okay, so here on page 67, we're going to look at proportions and similar polygons. Now, I say polygons, but we're going to look at some triangles too. Triangles are polygons in this section. So similar polygons have the same shape, but are different in size. Okay, when they have the same shape, this means that the angles are congruent. Okay, and on our learning targets here, this angle similarity, that means if two angles are congruent, then the two shapes are automatically similar. Which when we talked in the last unit, you can't have angle. That's because it only makes similar polygons. It doesn't make congruent polygons. And when we talk about different in size, this means that their sides are proportional. Okay, so their sides are proportional. So in this lesson here, I've got 4 examples. So we're going to go ahead and split our page into quarters. Like so. And our first example says that triangle, sorry, I got to turn the lights on. Triangle RST is similar to triangle XYZ. Or sorry, is. So are those triangles similar? So we've got this triangle RST. We've got this triangle XYZ. And then they give us some side measurements. So this is 25, this is 30 and 20, this is 15, 18, and 12. Okay. So the thing that we have to figure out is really are my sides proportional? Okay, and if the sides are proportional, then the angles will be the same and your two triangles will be similar. So we need to look at the corresponding sides. So RS corresponds with XY. So you got 25 over 15. And that has to be the same as your next one. So we'll go 30 over 18. And that has to be the same as 20 over 12. Now, though they don't look the same, we need to reduce these fractions excuse me, we need to reduce these fractions to see if they're actually the same. And we want to reduce them as low as we can. So the lowest that 25 over 15 can be is if I divide it by 5. So 25 divided by 5 is 5 over, and 15 divided by 5 is 3. Now my goal is to get this to each one to be 5 over 3. So 30 divided by 6 is 5, and 18 divided by 6 is 3. So that one works. And we also have to check the last one. If I make 20 and divide that by 4, I get 5. And 12 divided by 4, I get 3. So we took this one divided by 4, this one divided by 6, and this one divided by 5. So I get 5/3, 5/3, 5/3 is a scale factor. And all of these, so scale factor, all of those are the same. So yes, the triangles are similar. All right. And our next one, they give us M N P B S T. They're going to give us some sides. 8, 4, 10, X. Okay, and the directions are on this one are find X given triangle MNP is similar to triangle BST. Okay, so there are a ton of ways that you can look at this. Oh, sorry, I didn't mean that it was off the screen there. There are a ton of ways you can do this. And I'm just gonna list some out, and you can find the best one that works for you. But we need to set up ratios for these two triangles. Because they are similar, their sides are proportional. So we're gonna set up some proportions. So I could say 8 over 10 equals 4 over X. That's one way I could do it. Another way, I might say 8 over 4 equals 10 over X. Okay, again, that one's very similar. Now, some people don't like their X to be in the denominator, and that's fine. We can rearrange it and set it up a bit different. We could say 10 over 8 equals X over 4. And that's just kind of flipping this one around a little bit. And the last one that you probably don't see and you're really not going to use, and that would be, we can set up something like 8 plus 10 over 10 equals, and we just do the same for the next one, and that would be 4 plus X over X. And again, you're likely not going to use that one in this class, but in upper level classes, there may be a reason to set it up this way for you. Okay, so we're actually going to use the one where X is on top. Okay, right here, X is on top. So in order to do these, I need to multiply the whole thing by your common denominator. Okay, the easiest way to find the common denominator is to multiply these two together. But in this case, if I take 8 times 4, I get 32. So I get a really, really big number. But I know that both of these numbers can become 8. So I'm going to multiply everything by 8. So then I take both fractions times 8. Well, this one has a denominator of 8, so it cancels this 8, and you just get 10. Or you could say 8 times 10 is 80. 80 divided by 8 is 10. Or you could say 8 divided by 8 is 1. 1 times 10 is, I don't know why I wrote 18. 10 equals. Okay, we'll say 8 divided by 4 is 2. 2 times x is 2x. So I like to do the division first. We'll divide both sides by 2, and x equals 5. When x is on the bottom, you have to put x in your common denominator. So I'll just do this one here. If I were to multiply the whole thing by my common denominator, that would be 10x. So we take 10x times both of these fractions. So you got 10x divided by 10. That's just x. X times 8 is 8x. 10x divided by x. The x's cancel and you get 10. 10 times 4 is 40. And then you divide both sides by 8. And 40 divided by 8 is 5. So again, we got 5 using a different method. Okay. All right. Our third example here. So we got 20, 16, 12, and 24. 20, 15, 30, and 25. And the question is, are the quadrilaterals similar or congruent? Okay, so let's just look at the angles here. So I got 3 lines, 1, 1, 2, 2, and a right angle. So corresponding angles are congruent. So that means that those two are the exact same shape. Okay, but just looking at them, I know that the sides are different. Okay, so they're not congruent shapes because your sides are different measurements, but I need to see if these things are proportional. So we look at the corresponding sides. So I've got 20 over 25. That needs to equal 16 over 20. That needs to equal 12 over 15. 12 over 15. And that needs to equal 24 over 30. Okay, so then we just reduce them into the lowest fraction that I can. Okay, so I think I can multiply, if I divide both of these by 5, 20 divided by 5 is 4 over 5. Okay, so we divided by 5 on that one. Here I'm going to divide by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. So I get the same one. And you really need to check every single one of these, because you could check the first 3 and then this fourth one maybe not work. Okay, so 12 and 15, let's divide by 3. So 12 divided by 3 is 4. 15 divided by 3 is 5. So that works. 24 divided by, let's see, 6. 24 divided by 6 is 4. 60 divided by 6 is 5. So all three of these are the same, and this is actually your scale factor. Okay, so going from here to here, this number is less than 1. So 25 times 4/5 is 20. So this scale factor is going this way. If I wanted the scale factor going this direction, I just flip it over. So from here to here, scale factor of 4/5. Going from here to here, scale factor of 5/4. Okay, so you just flip it over if you want the other direction. So yes, these are similar. Okay, they are similar. All right, and our last example is find x. Okay, so you got A, B, C, D, E. Change here for the numbers. So you got 18, 6, 12, 3, and here to here is x. Okay, so we've got two triangles here that are overlapping. And to solve these, it's easier if you draw them out to see what you're given. So we have a really big triangle, which is ABC. And then we have a smaller triangle, which is DEC. Okay, so we're going to take and we're going to label the side measurements. So AC is X, so that's X. AB, I don't know it. And CB, I have to add these two numbers together. So 18 plus 6 would be 24. So in that one, I just have these two sides. CDE, okay, CD, so this side right here, I don't really know, but I do know the whole thing is X, and this little part is 3, so that then this right here must be X minus the 3. Yeah. DE is 12, and CE is 18. All right, so now what we're going to do is I'm going to use these two sides and these two sides, this one's not even needed, to form a ratio or a proportion like we did in the example above it. So it doesn't matter the direction you go. So we're just going to start here, X over, and you can put 24 equals X minus 3 over 18. Or you could have said X over X minus 3 equals 24 over 18. Either method will still get you the same answer. In fact, I think we're going to solve it both ways, okay? So the first thing here is I need to find the greatest common factor between these two numbers. Now, these are pretty big numbers. So the easiest way to find the common denominator is just multiply the two numbers together. So 24 plus 18, 24 times 18. You get 432. Now, I actually don't have to multiply these together to do this problem. I know I'm going to multiply by 24 times 18. And I could just write that up there. 24 times 18. And whatever number that is, you're going to multiply by both fractions. Okay? So when I take this number divided by 24, my 24s cancel, and you get 18 times x. Okay, when I multiply here, I'm going to take 24 times 18 divided by 18. Your 18s cancel, and you have 24 times x minus 3. Okay, again, this is from algebra, maybe a little bit harder. We're going to distribute, so you get 18x equals 24x minus, let's see, 24 times 3, 72. If I subtract 24x, 18 minus 24 is negative 6x equals negative 72. Divide by negative 6, and you get 12. So x in that case is 12. Now, I should get the same answer when I do this one. So we're going to multiply the whole thing by your greatest or your common denominator, which would be 18 times x minus 3. Okay, so I'm going to take 18, I'm going to take this thing times both of these. Your x minus 3's will cancel, and you'll get 18 times x equals. Here, your 18s are going to cancel, and you get 24 times x minus 3. Now, if you notice, these two steps are the exact same. So in the end, I'm still going to get 12 by going through this process. So we can kind of skip that process. Okay, so it doesn't really matter the way you organize your proportions. It's the algebra that may trick you up. Okay. So I'm going to post some practice problems for you. This is all we have on the D point or the 5.2 learning target, is just finding the missing numbers, okay? Seeing if they're similar and finding some of the missing numbers. So we had 2 examples on one and 2 examples on the other. So I'll put some practice problems up, and then you will have your 5.2 quiz. If you have questions, feel free to reach out. As always, thanks for watching. I'll see you in the next lesson.